PeerGFS is a software solution that enables active file services through real-time synchronization between data centers, public cloud regions, or in hybrid cloud deployments. This allows distributed teams of users to collaborate on the same project files by keeping each site up to date with the latest versions of files, whilst leveraging real-time distributed file locking to prevent file version conflicts. PeerGFS reacts to file activity in real time, so when a new file is created or a file is modified, PeerGFS will see that event and will copy it to all the other locations to keep each participating file server up to date. This allows users at each site to safely collaborate on files whilst enjoying the performance benefits of fast, local access to data or up-to-date files in a cloud-hosted platform. When combined with a DFS namespace to handle failover situations, PeerGFS provides a highly available files platform. When one site fails because of a network or some other outage, the users would be automatically switched from the unavailable file server to one that is still available, so that they can continue to work. When the downed file server comes back online, PeerGFS would automatically resynchronize it to bring it back up to date and would then instruct the DFS namespace to add it back as an available folder target. This method of failover, resynchronization and failback helps to reduce both RTO and RPO. PeerGFS can also be used to protect data at edge locations, with continuous data protection to a main data center, or of course the cloud, and because of our no vendor lock-in policy, all data is stored in a native format wherever it resides. In this video, I'll show you how easy it is to get started with a PeerGFS deployment in Microsoft Azure. To get started, browse to azure.microsoft.com. Click Search in the top menu, then type PeerGFS in the search field and press Enter. The search result will list Peer Global File Service in the Azure Marketplace. Click that to be taken to the page in the Azure Marketplace where you can then click the Get It Now button to proceed. If you need to, enter your basic profile details into the form. I've already done that, so I'll click the Continue button. You'll then be taken to the Azure Portal where you can create a deployment from scratch or start with a preset configuration. For this demonstration, I'll click the Start with a Preset Configuration button. You'll be asked to choose recommended defaults that match your workload. This marketplace offering is based on a Windows Server 2019 Core VM pre-configured with the Peer Management Center. Our recommendation here is to create a general purpose VM with at least 4 CPU cores and 16 GB of RAM. The Peer Management Center, or PMC, is the central hub that facilitates the synchronization of files between participating file servers at different locations. It uses a star topology, or hub and spoke, with the PMC as the hub, distilling real-time file activity from peer agents, and then orchestrating the copy of data from where it's been created or modified to the other participating locations to keep them synchronized and up to date. Click the Continue to Create a VM button when you're ready to proceed. First, we'll complete the basics. In the first field, make sure that you have a valid subscription selected. Next, click the Create New link to create a new resource group. I'll call this Peer Global File Service. Remember, when choosing a name for the resource group, that you can only use alphanumeric characters, periods or full stops, underscores, hyphens, and parentheses. You can't include space characters. In the Instance Details section, enter the name of the virtual machine that will host your Peer Management Center. I'll call mine PMC. Next, choose an Azure region in which to host the VM. I'll host mine in East US 2. In the Availability Options field, choose the type of infrastructure redundancy that's right for you. For this demonstration, I won't choose any infrastructure redundancy, but as mentioned, you should make a choice that's right for you. The Image field should be set to Peer Management Center, PeerGFS, and the current version. You should leave the Azure Spot Instance checkbox unticked. For the size field, as mentioned before, we recommend a general purpose VM with 4 CPUs and 16 GB of RAM, which if you click the drop-down menu, you'll see in the Recommended by Image Publisher section. So let's choose that. In the Administrator Account section, enter the credentials for the administrator account on the Windows Server VM that'll be created. You'll need these if you ever want to RDP or remote desktop into this VM. Finally, in the licensing section, choose whether you want to use an existing Windows Server license that you have or not. I don't have one, so I'm going to leave that checkbox unticked. Click the Next Disks button to specify what the storage will look like. In the OS disk type field, choose the Premium SSD option and the default encryption type. Click the Next Networking button to continue. The defaults here will all be fine, so click the Next Management button to continue. Scroll down to the Auto Shutdown section and untick that checkbox. Tick the Enable Disaster Recovery checkbox if you want your Peer Management Center machine to be spun up in a different Azure region in the event of an outage. For this demonstration, I'll leave that unticked and we'll click the Review and Create button to have a look over the specifications that we've just configured. That all looks fine, so I'll click the Create button at the bottom of the page to have the VM created. Now we have to wait whilst the various components get deployed. When you see that your deployment is complete, click the Go to Resource button. In the Essentials section, we can see the public IP address. Make a note of that, as we'll need it later on when accessing PeerGFS's web-based interface, as well as when deploying the Peer Agent software. The agents at each participating location will need to know where to connect to the PMC, and you can also use this address to RDP into the machine if needed. You can see that the DNS name for the machine hasn't been configured yet, and you can optionally use that as the connection point for the web interface of the PMC, the Peer agents, and for RDP purposes. So let's get that configured now. We'll set the IP address to be static and provide a DNS name label of PMC. When added to the rest of the domain, we'll be able to access the PMC machine at pmc.eastus2.cloudapp.azure.com, or of course by using its static IP address directly. Click the Save button when you're ready. Next, to tighten security, we should create an RDP Network Security Group or NSG rule to lock down remote desktop logins to a specific trusted IP address or addresses. Click the Home link on the top left. In the Recent Resources list, click the Peer Global File Service Resource Group, followed by PMC-NSG. In the Inbound Security Rules list, click Default Allow RDP. Change the source field from any to IP addresses. In the source IP addresses /CIDR ranges field, enter a comma-separated list of IP addresses that are allowed to RDP to the PMC VM. For this demo, I'll lock this down to the public IPv4 address of my machine, which is 81.152.157.25/32. If you need to find your public IP address, browse to the whatismyip.com website or do a Bing search for my IP. Click the Save button when you're done. Now let's log on to the PMC for the first time. In your browser, browse to port 8443 on your PMC VM's IP address or DNS name. It'll look like this: https://pmc.eastus2.cloudapp.azure.com:8443. Your browser might show you a warning about the connection not being secure, which is caused by the self-signed certificate that's shipped with the Peer Management Center by default. To proceed, if your browser says that the connection isn't private, click the Advanced button and then the Continue link to open the PMC homepage. Here you have links to the PMC web client and the user guide. Let's click the web client and get logged on. The default username is peeradmin, and the default password is peer2021 ! with a capital P. When logging on for the first time, you'll be asked for the PeerGFS license, which you should have received from your peer representative. If you can't find yours, or you'd like a trial license to test PeerGFS, reach out to the local peer office for your region. You'll find contact details for your local peer office at peersoftware.com/contact. Now I have mine saved on my desktop, so I'll click the Add Update button to get it added. There. Click the Apply and Close button when you're done. The next step is to install a couple of peer agents and connect them to the Peer Management Center that we've just deployed in Azure. When connected, they'll be listed in the Agents pane here on the bottom left. For this demonstration, I'll use a couple of Windows file servers, but please keep in mind that in addition to Windows file servers, You can also use PeerGFS to synchronize files between other storage types too, such as NetApp Fabric attached storage, Nutanix files, and Dell EMC storage. The ability to synchronize files between different storage types is definitely one of the strengths of Peer Global File Service. You can download a copy of the Peer Agent installer from the PMC by clicking the Help pull-down menu, followed by Download Peer Agent Installer. When you've downloaded it, copy it across to the Windows file servers and run it. I'll switch to the first of my file servers and will install the Peer Agent and get it connected. I've got the Peer Agent installer already downloaded for convenience, so let's get the installation underway. When you've accepted the license agreement, verify that there's enough free disk space. You should have at least 50 gigabytes of free disk space available to accommodate the log files. Click the Next button to proceed. In the hostname field, enter the IP address or DNS name of the Peer Management Center VM. In my case, that's pmc.eastus2.cloudapp.azure.com. If your Peer Agent will communicate with the Azure hosted PMC via an already encrypted VPN or VNet peering, use TCP as the protocol. Otherwise, use SSL to encrypt the traffic. By default, the traffic will flow through port 61616 for TCP or 61617 for SSL. It's worth making a note of those ports because if the Peer Agent doesn't successfully connect to the PMC, you'll want to ensure that any firewall in between is configured to allow traffic through the relevant port. Click the Next button when you're ready. You need to enter account credentials for the Peer Agent service to run under. It's important that the account is a member of the administrators group on the machine, and you can check that by right-clicking the Windows Start menu and selecting Computer Management. Expand Local Users and Groups in the left-hand pane, and then select Groups. Double-click the administrators and use the Add button if needed to add the account to the local administrators group on this machine. My account is already there. Back in the Peer Agent Setup dialog, finish entering the credentials. And then click the Next button to proceed. Choose whether you want a Start menu folder for the Peer Agent, and then click the Next button. The installation will then commence, and when complete, you'll be able to click the Finish button. At this point, the Peer Agent service will start and it'll connect back to the Peer Management Center. We'll check that it's connected in a minute, but first we'll install the Peer Agent on a second file server. It's the same procedure as before. We'll start the installation and accept the license agreement. Next, we'll check that there's more than 50 gigabytes of free space, then click the Next button. Then we'll enter the IP address or DNS name of the Peer Management Center VM in Azure. And click the Next button. Next, we'll use computer management to ensure that the account we're going to give the Peer agent to run under is a member of the local administrators group. Click Next to continue. Like before, we'll allow the creation of a Start Menu folder for the Peer agent and click Next to allow the installer to complete. Now that we have our Peer agents installed on the Windows file servers, let's switch back to the Peer Management Center and check that they've successfully connected. There, in the Agents pane on the left-hand side, you can see that both Peer agents have successfully connected. We can now create a file collaboration, replication, or synchronization job. The difference between them is that a replication job is a one-way movement of files from source to target. A synchronization job is a multi-directional movement of files. If a file is created or modified on one file server, it'll be copied across to the other, and vice versa. A collaboration job is also a multi-directional movement of files, but additionally includes real-time distributed file locking to prevent file version conflicts. This means that if a file is opened on file server A, the local copy of the file on file server B would be locked and could only be opened as a read-only file until the user on file server A had finished their edits and closed the file, thereby lifting the lock. It prevents more than one version of the file being created at multiple sites. Let's create a quick synchronization job and check that everything works. Click File and then New Job, and then choose File Synchronization and click the Create button. Enter a unique name for the job, such as Test Sync Job, and click the OK button. In the Participants dialog, use the Add button to add the first file server. Then use the Browse button to specify the folder that you want to keep synchronized. I'll choose the Data folder on drive E. Then click the OK button and then the Finish button. Now I need to do the same for the second file server. So we'll click Add, choose the second file server, and then browse to the folder that we want to synchronize. There, finish when done. Now with both participant file servers included, I can click the Next button and specify what access control list or ACL metadata I want to have synchronized along with the files. As these file servers are both part of the same domain, I'll tick the first checkbox to have the ACL metadata synchronized, and a warning will pop up stating that all participating hosts should be a member of any referenced domains that are configured in the ACL or ACLs. Basically, if you were synchronizing between two disparate domains with no trust between them, you wouldn't want the ACL metadata to be copied too, as the file owner information would mean nothing on the other side and could render the files unreadable on the remote file server. I'll click the OK button to acknowledge the security descriptor warning. I'll also click the second checkbox to have the ACLs copied from a master server during a scan, and I'll also choose which the master server will be. In the security descriptor options, choose what types of metadata to synchronize. I'll have all three: the owner information, the DACLs, and SACLs. I won't set up email alerts for this demonstration. There is a separate video that delves into that in more detail on the Peer Software YouTube channel, along with a lot more peer related content. So check that out if you want a walkthrough on email alerting. For now though, I'll click the Finish button and we'll test that the synchronization is working between the two file servers. Good. Our synchronization job has been created, so let's right click it and start it up. When the status here says that it's in a running state, we will be able to test the job. So we'll wait for that, and then we'll switch over to one of our file servers and create a file in the data folder. Good. Now let's check that the new file has been synchronized with the other file server. There it is. Now let's rename it and make sure that the change gets copied back to the first file server. Good, the synchronization is working, so let's edit the file and enter some content. Now let's switch over to the other file server and make sure that the content of the file has been copied across. There, it has. So, we've deployed a peer management server in Azure from the Azure Marketplace and used it to demonstrate file synchronization between a couple of file servers. Remember that you're not limited to just two file server participants, and for that matter, not just limited to synchronizing or replicating between Windows file servers either. PeerGFS also supports storage from NetApp, Dell EMC, and Nutanix, and you can synchronize files between any of them. You're not limited to just one storage type. I hope this video has been helpful. If you'd like further assistance from one of our engineers, feel free to get in touch with your local peer office. Details can be found at peersoftware.com/contact.